In this video, we're going to look about finding the values of x for this given function f of x equals the square root of x cubed minus 6x squared plus 9x plus 4, where the tangent line is horizontal. So we've got a couple of things to think about. First, we're asked to find x values, so we're solving for x, but we're solving for x where the tangent line is horizontal. So what we know about this is that a horizontal line has a slope of 0. Remember, derivative represents the slope. So we need to find the derivative, and then we're going to say, well, where is the derivative or the slope equal to 0? And that is going to give us our x values. So let's find the derivative. Now, when we look at this, we have a polynomial underneath a radical. So this is a composition function. And when you see a function composed of another function, that's going to indicate you'll need to use the chain rule. Now in this situation, to use the chain rule, I'm going to rewrite that square root as a positive 1/2 power. That's going to allow me to take the derivative. So we've got the derivative of the outside. And once we find the derivative of the outside here, then we will multiply by the derivative of the inside. So if I were to write this out using my power rule for this first half, I would say 1/2, and then this entire expression is still in there. So 1/2 x cubed minus 6x squared plus 9x plus 4. Subtracting 1, that gives me negative 1/2. But then, of course, we need to multiply by the derivative of the inside, which is x cubed minus 6x squared plus 9x plus 4. So we need to find this inside derivative, and then we will be done calculating the derivative. So f prime of x, I'm not going to simplify anything yet. I'm just going to write this out. So we've got 1/2 times the quantity x cubed minus 6x squared plus 9x plus 4 to the negative 1/2. And then we have times the derivative of the inside, which is 3x squared minus 12x plus 9. I found the derivative of each of those terms using the power rule. And of course, the derivative of a constant was 0. So now I'm going to simplify my derivative expression. So I end up with f prime of x. And this is in the numerator, so I've got 3x squared minus 12x plus 9 in the numerator. And in the denominator, I have 2. Remember, a 1/2 power is going to go to the other side of the fraction, so that is a square root in the bottom. We have x cubed minus 6x squared plus 9x plus 4. Now we have found our derivative, and let's think about what we're trying to solve. We're trying to solve where the tangent line is horizontal. Now the tangent line, the slope of the tangent line comes from the derivative. So essentially, the derivative means the slope. So we want to solve that derivative equal to 0. So I'm going to say 0 instead of f prime of x equals 3x squared minus 12x plus 9 over 2 square root of x cubed minus 6x squared plus 9x plus 4. Now, we want to solve this equal to 0. We have a rational equation. So right now, I'm going to treat this 0 like it's over an invisible 1. 0 over 1 is still 0. And I'm going to cross multiply. So 0 times the denominator, 0 times anything is going to be 0. And then that equals 1 times the numerator, which gives us 3x squared minus 12x plus 9. So essentially, we just get the numerator equal to 0. And that's going to happen anytime we're solving a rational expression or rational function equal to 0. All right, so this is quadratic. I'm going to solve this by factoring out 3. So that gives me x squared minus 4x plus 3. I can divide on both sides by 3, so 0 just equals x squared minus 4x plus 3. This is factorable, so I have x minus 3, x minus 1. And by the zero product principle, I end up with x equals positive 3 and positive 1. So at x equals positive 3 and at x equals positive 1, my graph will have horizontal tangent lines. So let's go back and we'll think about what does it look like if I plug my original function into the graphing calculator. So if I were to graph y equals my original function, I get a cubic graph that is sort of truncated or cut off here because we've got that square root, defining it so that it is greater than or equal to 0. And you'll notice that the max and the min are occurring at positive 1 and positive 3. And if you think about drawing the tangent line at both that max and min, we would have a horizontal tangent line. So, you always have your graphing calculator with you. Just make sure you're looking at the graph and using that to support your work and to check yourself. So I hope this helps. Please let me know if you do have any questions.